Hello, everyone. Thank you so much for joining us for today's WiCyS webinar. My name is Morgan Garland. I'm the board liaison with WiCyS. And with me today, I have Varsha from Google, who's going to be presenting the webinar. Before we get started, though, I just want to share a few slides and give you all an overview of the WiCyS organization for those of you who are not familiar with us. We are a nonprofit 501c3 with a mission to recruit, retain, and advance women in cybersecurity. We often go by our acronym WiCyS, as in We Sisters, because that is exactly what we are. We are a global cyber sisterhood. We have over 11,000 members in over 100 countries. We have 68 professional affiliates, over 300 student chapters around the world. We offer a variety of different skills development training programs for all career levels. We have our monthly newsletter that goes out, our annual conference, which is coming up March 11th to 13th in the Washington, D.C. area. Our Job Board Plus Plus is open year-round 24/7 for our strategic partners to post job openings and for our members to apply. And then we have our online member platform, our senior ally network, and so much more. Some of our current programs right now that are open for enrollment, you can find on our website at WiCyS.org and navigate to the programs page. Right now we have our VDP program, our SANS Executive Cybersecurity Exercise, our book club, which just happened today, and a lot of more programs are being added every day. So go ahead and check that out to see what you can enroll in today. And all of our programs and skills development training initiatives are brought to us by our strategic partners. Our tier 1 partners are Akamai, Amazon, Bloomberg, Cisco, Ford, Google, Lockheed Martin, Palo Alto Networks, and SentinelOne. And please ask questions today. You should see a little chat box on your screen where you can drop in questions throughout the webinar. We do have time reserved at the end to answer all of your questions. And if you haven't done so already, please subscribe to the WiCyS newsletter to stay up to date on all of our upcoming events and initiatives. And you can do that again at our website at WiCyS.org. With that, I'm going to turn it over to Varsha to kick off today's webinar. Thank you, Varsha.
Thank you, Morgan. Okay, firstly, thank you for everyone who's joined here today for this webinar. I'm going to be focusing today on something called threat hunting. So to start off, let me introduce myself. My name is Varsha. I am an incident response consultant at Google, and I work in the Mandiant incident response team. I'm based out of New York City. I originally came to the US to do my master's in computer science. From there, my career was very focused with like data science, data analytics, but then I had a keen interest in cybersecurity, and I eventually got into the cybersecurity space. I have been in this space for 5 years. And so, yes, I am a newbie. I'm still learning. I'm still very much a mid-career professional. So I just wanted to do this presentation to kind of go into the work that I do and to talk about how threat hunting is, it's kind of changed the threat landscape today to not just do incident response and post-incident investigations, but also to hunt for threats that are currently in your environment, to currently that need to be caught way before it leads to the data extortion, ransomware, and data theft stage. So today I'm going to be talking about a particular threat actor group. I wanted to kind of get into like a threat actor group, not just because that's like the most craziest threat actor group out there. It's more about having a good example to go off of. And for that, I'm going to be focusing on UNC3944. So what is UNC3944? So basically, they also go by the name called scattered spider. That's something that you might have heard before. We can see here that they are targeting a lot of the Canada, US, India, Australia regions. Initially, when they came, when they started to cause chaos, it was back in May 2022. Their initial focus was credential harvesting and SIM swapping, and from there they kind of moved into a lot of social engineering tactics like the voice over IP phishing and help desk calls. From there, we see them now, like as recent as 2025. They are really, really big on data extortion now. They have even like gone past the ransomware stage, and they're focusing a lot on data extortion techniques. So before I kind of delve into what the threat hunt methodology is, we need to understand what the attack lifecycle is. And of course, the best place to go to look at this is the MITRE attack lifecycle. To start off with, we want to see what the initial compromise and initial attack vectors are. So with UNC3944, we see them use, like I said, SMS phishing campaigns and help desk phone calls, SIM swapping, with the establishing the foothold or the initial access post the phishing. We see them basically using compromised credentials to gain access. When it comes to maintaining persistence, we see them use a number of remote access tools and also create new VMs that are publicly accessible by them. We also see, then we move on to how they move laterally, where we see them use Mimikatz and a lot of credential dumping tools, credential harvesting tools to kind of escalate their privileges, move laterally. And the actual lateral movement, we see them use RDP, SSH, and internal network logons. When it comes to recon to figure out what to steal, where to go, we see them use a lot of these commonly used info stealers, a lot of command line tools, and to complete their mission, their main focus we see is data extortion. With that, we see rclone, Megasync, AnyDesk, Dropbox, Storage Explorer, all of these tools. We have seen them use Alpha V as their ransomware variant to decrypt the files on the system. But again, like I said, we have seen them go away from the ransomware model to just data extortion. So to reiterate the core characteristics they have: vishing, social engineering, all sorts of identity-based attacks where they are trying to bypass MFA and get into your systems, hypervisor and cloud focus, because they are at the end of the day trying to create new VMs and exfiltrate data from the VMs. So before we get into what actually I'm going to talk about today, threat hunting is something that that all firms are doing something today very new. Usually we focused on incident response methodologies, which is basically post-incident exploits, like, well, how did they get in? What happened? What data was taken? What artifacts are showing this evidence for us? What accounts did they touch? What credentials do they have? All of this is more of a reactive methodology, and that, as useful and important as it is to really do your post-mortem, it's also important to be able to detect them and try to save yourselves from being in that place in the first place. So this is where threat hunting comes into play. You want to be able to hunt for threats already existent in your environment. And that's the reason that I chose this complicated threat actor here. Scattered Spider has been around for a very long time now, and they have I have personally been on engagements where I've seen them literally steal gigabytes of data from the environment. So it's important to be able to build a whole methodology to be able to to be able to trace them and hunt for them right from initial access to data extortion. So we start off with our, the most important hunt, which is initial access. If you're able to capture if you're able to capture and find evidence of UNC3944 at this stage, it's basically a form of containment. You have already contained the incident if you catch them at this stage. So with initial access, we see these methodologies. We see them repeatedly call the help desk. We see them trying to reset account passwords of extremely privileged accounts. We also see them add MFA devices or remove certain older MFA devices and add their own MFA device. And of course, impossible travel is one of the best ways to figure out if there is something anomalous, something suspicious happening, also by looking at any other suspicious IPs and logins. So let's get into these one by one. The first thing we see here is privileged account password resets, right? So I'm going to be talking about M365 and AWS as our platforms for today. But again, every firm, every company has they have their own ways of where the logs go to. And M365 is not the only platform that has a SIEM, right? We have multiple number of SIEMs and EDRs, all of which might have logging that would help us create and execute these hunts. But today I'm going to be talking about just these two. It's all about how you want to write queries or navigate to your portals of the EDRs and SIEMs that your firm uses. I'm going to be talking about M365 now. There's two kind of hunting that I'm going to be talking about. One is something really simple where you're just in the GUI, like the user interface, and you're navigating to where the logs are, and you're just looking through the logs using filters and simpler ways. Whereas the other is, which is the more effective way to hunt, is writing an advanced query. Both have their advantages. When you're writing a simple query, it's when you're doing the simple way by going to the GUI, it's really useful if you want quick wins. You want quick wins where you're not wasting time developing a query. You want like a quick win. You want to be able to like you suspect that one user has been compromised, and you want to quickly go check if that user's password has been reset. That's when this comes into play. So this is basically your previously M365 called this Unified Audit Logs, but now it's just under audit in the Purview portal. So this is a screenshot of that. You can see the activity section where it says activity column where it says reset user password. That's pretty much the smoking gun here. That's what you need to find. So again, like I said, you navigate to the Purview portal and then you click on audit, and then under activities, there's something called friendly names, which actually makes our lives easier. It basically is like an English name where you don't have to look for the actual event name. All you need to do is just look for like change password, and you will find these three friendly names, which is reset user password, change user password, set property that forces user to change password. The third one is something that admins would use to enforce a password change. This is important if you think that an admin account has been compromised and they're trying to change someone else's password. Again, when you are trying to hunt in general, you're trying to look for password changes for admins and highly privileged user accounts. Another way to kind of do this is the querying. And this is my favorite. I think that all of us should be able to learn how to query, because now there is no way that what a GUI gives us, like the user interface gives us, that is never going to be sufficient to get the full picture. Unless you are very particular or you're very sure about the exact, like, narrowed down hunt that you're doing, this is the best way to do it. This is something, again, that has to be enabled. Advanced hunting has to be enabled in M365 for you to be able to run this query. But again, like I said, it depends on the firm and your firm. If they are forwarding logs to an external SIEM like Splunk, then you would be able to query that on Splunk. But in this case, we're talking about M365. So you go to security.microsoft.com, hunting, advanced hunting, and there the query exists. And this is basically the Custo query language. That's the query language you're using. It's, again, there is a learning curve to that, but we have our AI tools. We can always develop good queries to be able to actually get to what we're trying to find. In this case, I'm just looking at the Cloud App Events table, where I'm just looking for these three events that we just saw in our friendly names: reset user password, change user password, and update password profile. I'm trying to output all of this in a table. I'm trying to get the target user, like the users whose password was changed. I'm trying to get the actor, or the one who changed the password. I need the IP address, which is the most important thing here. And then and the result status is also going to be important, where if it is 0 or a success, it basically means that it was a successful operation. There could also be failures for a lot of reasons where, it's not as important because the operation failed. So yeah, I'm trying to get all of this information and of course the timestamp and put it into a table so I can look through them and focus on my admin accounts, privileged accounts. And coming to AWS, again, even here, I'm going to be talking about two ways to hunt. One is through looking at the user interface. In this, it's again really simple. I'm going to go to AWS, CloudTrail, and under CloudTrail, this also has to be logging that has to be enabled. But by default, you do get 90 days of event history. And I think I forgot to mention this, but in M365 as well, we get 90 days of data. In AWS with the CloudTrail, we go to something called event history. We can filter for the change password and update login profile events. And if it's a root user, that's going to be kind of like separate, but if it's a root user, that is extremely bad if you see a root user password change. So that's again something you need to look for and flag a password updated event for the root user. And when it comes to the normal change passwords, focus on your admins and users with high privileges. And usually when you look at like a full event history table here and focus on the user whose password was changed, you would see like a login first and then a change of password. This is the same thing, but again, by using a query, it just makes things simpler by putting everything into a table. The way to query in AWS is you go to the Athena console and use the query editor. The thing to note here is, like M365's advanced hunting, the table names are not already defined. Usually these are things defined by your AWS admins, like the CloudTrail database. It could be named according to your naming standards. It's not going to be a fixed name. Moving on to the second initial access hunt. MFA device changes. So we're trying to see if there have been any changes to MFA configurations, which includes deletion of an previous MFA device that the legitimate user was had set up, and the addition of a new MFA device, which is a big way which is one of the main ways that threat actors maintain persistence. So user register security info is the activity name that you're going to be looking for in M365. The way to kind of go to this page here is you go to something called audit logs. It's not going to be under purview or like where we saw before. It's not going to be a part of the Unified Audit Logs. It's going to be a part of Entra ID's audit logs. So you're going to be seeing an activity name called user registered security info. And there's also, again, a very simple way to run a query to get the same information. The action types can be any of these: user registered security info, user registered all required security info, and admin registered security info. This is, again, just giving you the device details, which is really important to know because you want to know what device it was, and you're also trying to get the user who added this device. The same thing with AWS. The event names to look for here is enable MFA device, create virtual MFA device. Both of these are big ways to see who added the device and what the device details are. Moving on to the third initial access hunt, which is, again, I think the biggest and the best way to kind of find your indicators of compromise, your IP address that actually is the starting point to the initial access. And once you have that IP address that did the successful login into your system, you want to block that, you want to flag that. The other thing to note here is I am focusing here on successful logins, but it's also super important to make sure that you're keeping an eye or having a detection mechanism to detect failed logins as well, because that's how you would know if if your account has been compromised, if the credentials of your account has been compromised. You want to be able to see why the login failed. If the failure was due to right password but bad MFA, then you know that the password was right, which means that someone out there has the credentials to that account. And that's something to keep an eye out for, and also have a detection rule in place to see how many failed logins we have coming in from bad IPs like this. So in this screenshot here, I have just successful logins, and I'm able to see this one IP there, the 4586.202.170. This is coming. This is a successful sign-in from Nicosia, which isn't even in the US. So you want to be able to, you want to notice that, because the geolocation is suspicious. You do not know this employee ever, this employee whose account, the admin underscore user at company.com, whoever that account belongs to, you do not recognize a login from a country that's not the US. And you want to be able to understand why this is happening and investigate further. So when you find this, you want to do one main thing, which is IP enrichment. IP enrichment is it's as simple as Googling the IP, but if you want more accurate and relevant information, there's two things that I usually use. One is VirusTotal. You always have VirusTotal to put the IP in. You're going to be able to see if it is attributed previously to a threat actor. That information can be inaccurate sometimes, because at the end of the day, an IP address that could have been rolled off to another organization, it could actually very well be legitimate. Or it could show up as legitimate on VirusTotal, but could now be used by a threat actor. So that's always there. But one thing that does help is to look at something called Spur. Spur.us is, I'm going to go back to the AWS slide, but I just wanted to talk about this. The Spur.us is one of the tools I use to kind of look up IPs, because this one tells me if it's a proxy or a VPN, and it tells me the date that it was last seen as this proxy or VPN. It shows me the location. It shows me if there's a geo mismatch. So yeah, this is one of the ways that I see. And if you see like a VPN usage or proxy usage, you know that there could be like actual tunneling that's happening, which means that this is unless the VPN is approved for usage by your firm, it's definitely suspicious, because you do not know of anyone actually using VPN or VPN service from your approved devices. And secondly, if it's a proxy, it is a way of defense evasion. They're trying to hide their true, the true origins. So this is the platform I use. There's a couple more. There's IP Info, VirusTotal. All of them are good ways to kind of do some IP enrichment. There's a lot of open source intelligence blogs where you can go up and see if this IP is actually an indicator of compromise in the UNC3944 IOCs listed by either the CISA or the various other blogs where people have actually done investigations and have the indicators of compromise out there in public. The other way, just going back to the querying, the other way to kind of look through this is by using the query. This is doing the same thing. It's basically just looking for a logon success. And it's trying to only capture those where, like, it's also trying to make sure you have an MFA column to see if the MFA, if the MFA was used or if it was single factor. So that's this query. And then with AWS, we have something called console logon. So we don't really have exactly what M365 gives us, but it pretty much gives us the same things: console login, and is MFA used, not used, and the IP address. So this is the first hunt. I'm going to be going over the rest of the hunts now. If there's any questions, please drop it in. I'm going to be doing a Q&A at the end. I'll try my best to get to all of them and answer to the best of my abilities. The next hunt we are going to be talking about is escalating privileges. Like, the threat actor is now going to be trying to try to gain access to more privileged accounts. The few ways that UNC3944 is known to do this is credential dumping tools, where they're trying to get the credentials to promote privileged accounts. Minicats, go secret dump. And then the other way to do this is to access like a password vault, and with that they're trying to go to CyberArk, HashiCorp, and a secret scanning artifact, Trufflehawk, GetGuardian. Usually these are tools used legitimately by penetration testers, but Of course, they have their vulnerabilities. They're easily, if you do not have detection and mechanisms in place, it's very easy to run these tools and actually get access to passwords. This is a really simple hunt. It's all about how you're going to be looking at tools. In M365 here, this is an endpoint hunt that I'm going to be going over. Um, right now, whatever we spoke, all the hunts, all the queries we spoke about until now were very cloud focused. They were hunts that were looking through the M365 accounts. But this is going over the devices in the environment. So it's basically an endpoint hunt. And sometimes this is not necessarily enabled because a lot of the endpoint telemetry, some firms don't even log them, but some firms actually send them over to different types of SIEMs and EDRs. They don't really send them to M365, but I'm trying to focus more on the hunting methodology, not really like it is not really like an M365 tutorial. So I'm still going to stick to M365. But again, like I said, there's different ways and different places that these logs could be going to. Uh, in M365, there is a separate set of tables for device events. This is one of the device events. It's called device process events, where it is capturing all the logs based on all the processes being executed on that system, on that endpoint system. So we're trying to look for a file name that has the word mimikatz, go secret dump, truffle hog, get guardian, and we're also trying to look for command line arguments, which has these terms there. Invoke hyphen mimikatz is a PowerShell CMD that's used to invoke mimikatz. So that's also included in this query. We also see the LSAS dump as a keyword here because that's again a very commonly used way to dump the LSAS credential, dump the whole LSAS into dump the whole LSAS. And with AWS, it's similar. We're trying to look at CloudTrail logs for any events that so CloudTrail logs is able to actually generate a separate event because they have, when it comes to running like certain API calls, they have certain API calls called get secret value, get parameter, and decrypt. So that's something we're looking out for here. And it's also known to use it when these tools are being run in AWS. We see user agents that have the name Truffle Hog and Git Guardian itself. So that kind of makes it simpler to just look for the user agent. So moving on, this is again a very, very important hunt because we're trying to see, yes, the threat actor already gained initial access, but did they actually not make it through because they were kicked out or they were shut down? The only way to see that is to see if they have any persistence mechanisms where there is a way for them to keep coming back or to stay on indefinitely until recognized. So these are the ways that we see Scattered Spider do persistence. We see them create new cloud accounts. We also see them create new VMs. And then one of the more commonly used ways is remote access tools that are usually like legitimately available to use or not blocked by IT. So let's get into each of these. Creation of new cloud accounts. It's basically threat actors creating user accounts, and these user accounts, they escalated privileges and have access to a root account. But the more they do activity with that root account, they tend to get caught. So they are going to create a new account that is just like any other user account, and they're going to continue to stay in the environment and do whatever they want to do. So this is one of the best and easiest ways. You just look for an add user operation in M365. The way to do this using the user interface is you go to the Entra Admin Center. There is something called Identity, Monitoring and Health, and Audit Logs. Under the category there, this opens up the whole audit logs table. And again, make sure to fix the timestamp and the time frame based on what the time frame of the hunt is. Under category, you're looking for user management, and you should be able to see under activity, you should have a filter again for add user. If you have this activity, then again, you should go through it and see what the target username is, or the user that was added and who it was initiated by. This query here is the same thing basically, but as a query, you're trying to look for an ad user activity name and get the IP address, target user, and the time that happened. This is the same thing, but of course, AWS. We are again going to CloudTrail event history, and the event name here would be create user. Create access key is another important event that you should look for hand in hand with this, because once you create a user, you should be creating a user access key for continued access to that account. Creation of new VMs. The threat actor in this case is known to create new VMs so that they have their own publicly accessible VM that they can transfer data in and out of. So the way to monitor this is you go to the Azure portal, go to monitor, and go to activity log. And under that, you can filter for create or update virtual machine events. And that should show up all of the virtual machines that was created and any updates to a current virtual machine. That's possible too if they took a current one and converted that to public. So these are events to look for when you're looking at the UI. The query here, when it comes to certain VM activities, I prefer going to another place to hunt for this or to query for this. It's called the Microsoft Sentinel. So you go into Sentinel and you go under hunting, and you can create your own query that will help you look for this. The operation name you look for is Microsoft.compute virtual machines write. The write operation is basically a creation of a new virtual machine. Again, it's also not a bad idea to look for any deletions here. This will not really be a part of this hunt, but again, there is a write, there is a read, there is a delete, all very important operations to filter with your bad IP and to look at what they did. This is the same thing, but with AWS. In AWS, the event name will be run instances. That's the event you look for to see if they created any new EC2 instances, which is basically your VMs. So it's again going to be under CloudTrail event history, or you could also run the query in the Athena. Moving on, this is a very customized hunt. But in my opinion, if you are hunting for remote access tools in the environment, you should just be looking for every single one you can think of. This query here is focusing on the UNC3944, commonly used remote access tools. Again, this is very, very endpoint telemetry data with M365. This could again be in another platform, but right now I'm looking at the device events. I'm going to look at two types of device events, the process events and the network events. Process events is looking for the exact file name. So you have all of these, you have this query looking for all of these remote access tools, AnyDesk, Screen Connect, Splashtop, Manage Engine, Zoho Assist, and with the network events, what I'm trying to look for is network connections to these, to the web browser aspect of these remote access tools. So I'm looking for TeamViewer, Splashtop, Screen Connect, but I'm looking for the web versions of these. Like I'm trying to see if they access these URLs and did some sort of account creation, data transfer through these through the web, through the browser. With AWS, I'm not going into endpoint telemetry in AWS because I'm trying to look now for there's something called Systems Manager in AWS, where it's only going to talk about the inventory or applications installed that exists on any of the AWS instances. So this is not really focusing on endpoint data, but it's focusing on the instances in AWS and what applications each of them have installed. So by going through that route, if you want to go through the UI route, it's going to be a little slower because you will have to manually filter for the tool names. You can go to AWS System Manager, Inventory, and under the the application name filter, you put in like AnyDesk or Screen Connect, and it's going to take forever. So this is a good idea if you know for sure which tool you're looking to find. But of course, there is a way to look and find these tools by using the query, by using by using Amazon Athena, and that's by two things. One is, again, like I did with M365, you want to look for the DNS resolution hunt, which is basically you're looking for web connections to these commonly known RAT websites. And with the other one, you are querying the SSM, but in this case, it's a query, so you are able to actually query for all of the tools at once. Moving on to recon. So now I want to focus on how is a threat actor. The threat actor is passed through the persistence stage now, and now the goal is to move further into the system by finding out what they want to exfiltrate. Like, yes, I have the best going on here right now. I have persistence, I have access to root admin accounts, and I have an extra VM lying around here that I can use. What am I going to use this for? And that's what this hunt is. They want to now focus on using this to find out what crown jewels, what important and confidential data there is, and how and where I can find them to steal, or even to encrypt if their focus is ransomware. So moving on, recon is going to be three ways. One is AD and cloud enumeration, an enumeration of any form, which is they're just trying to find what domain controllers are there, or like what data is on these domain controllers. And the other way is to use info stealers. Another simple way is to use built-in recon commands. That is the way that most threat actors go undetected, because they are just using already inbuilt commands to grab confidential data. Focusing on the hunts now, enumeration tools, I can just look at all of these, and the info stealers all in one hunt, because again, I'm just trying to look for the tool names under device process events. I'm trying to look for the file names that has any of these: AD Explorer, Sharphound, Bloodhound, Advanced Port Scanner. I'm trying to get there. I'm trying to see if any of the file names match this. And then I'm trying to get the device that we see this in, the account name that is running this, and the command line, if any, that this tool is being run with. With M365, now I'm going to focus on the command line aspect of it with inbuilt tools like ping and nslookup and netstat and ipconfig. All of these, this could give out a lot of noise, but at the end of the day, we can focus on the accounts of interest and still try to get a good and readable output from this and go over it to see if there's anything suspicious. So even to make it simpler, this query is trying to see if this command count of commands that have these keywords are more than 8. Only then are we trying to see that, okay, this one particular user using on this one device has run an nslookup command like more than 8 times. And that's what we flag, that's what we review. AWS enumeration tools, again, we're going to look at CloudTrail logs, and we're trying to see if there's some, there is, again, an API call here that we can focus on. It's called get account authorization details. This API call is known to give a lot of very valuable information. Account authorization can have like information about EC2 instances, amount of S3 buckets, amount of data in it. And then you're also going to see this come from like certain user agents, which basically means it's like one of these like scanning or info stealer tools that's being run automatically in the background. It's not like manually happening. So this is a way to kind of detect and find your info stealer tools via the AWS query. The recon commands. When it comes to AWS, recon commands work very differently because all of it works through API calls, because we're not able to really look at endpoint telemetry with like actual PowerShell or CMD commands here. We're looking at API calls. With that, we have list users, list roles, list group when it comes to like the role related information, user and role related information. With S3, we have list buckets, get bucket location, list objects. And when it comes to EC2, we'll have describe instances, describe subnets, describe volumes, and things like that. Finally, they use this information and move laterally. And I'm talking about internal movement from one internal system to another. Commonly used methods, RDP and SSH tunneling. And the other way is valid account usage, where they're just using accounts that they already had access to. Like, so it's a valid account. It's not like a bad account. They're using a valid account, and they're logging into domain controllers. And then the final thing is a SOCAT Linux utility, which I'll talk about in a bit. Coming to RDP and SSH tunneling, we are trying to look for two things. With M365, again, we have endpoint data, so we're going to have event logs. The event logs are going to be in the table called device logon events in advanced hunting. We're trying to look for logon type 10. And we're also trying to see for remote desktop connections, which are basically your log event IDs 21, 22. And we're trying to get that information here. And with device network events as well, we can look for things like SSH and PuTTY to see if they're using these tools to log into any IPs with the source port of 3389, which is an RDP port, and 22, which is an SSH port. And we're also trying to make sure that we are focusing on our private IPs, like one private IP to another private IP. With AWS, you'll have to get into the VPC flow logs for this. Look for the same port numbers and also look for an accepted connection. Valid accounts. So going on to the valid accounts, we are trying to find sign-in logs that relate to accounts already existent. So we don't want to look at like your Azure sign-in logs. We're looking at sign-in logs into systems or VMs already existent in the system. So with that, the way to do that from the UI is to go to Entra Admin, Monitoring and Health, and sign-in logs. The device logon events will also have this information. We're trying to look for, again, type 3 and type 10 logons. Type 3 would be really important here to see if there's logons that are not RDPs. We want to still flag the network logons as well. This is with AWS. With AWS, we are trying to look at something called assumed role, which is basically an event. It's not really a lateral movement or a login. It's basically an event where there's one user who's assuming the role of another user, which just means that a user that had access to maybe just one VM is assuming the role of another user that has access to 5 VMs. And now the assumed role allows this original user, the initial user, to access all the 5 VMs. So the assumed role event is what we would look for when it comes to AWS. And again, this would be under event history. You can also run a query for the same thing. SOCAT. SOCAT is basically a Linux tool that establishes like a bidirectional connection. Like, it not only can connect to an external C2, but it can also reconnect back from the external C2. In this case, though, we are going to look for SOCAT for private IPs, as in the internal systems, because we want to see if there's a bidirectional connection established between two internal systems. And this kind of is also a persistent connection. So we, again, want to be able to flag this because Scattered Spider is known to use this tool. Again, with M365, we are getting into device process events. We're looking at the file name that might have the word SOCAT or the command line that might have the word SOCAT, and we're making sure the IPs are private. And the same thing with AWS. We're looking at two things. One is the CloudTrail logs, where we're looking for an event name itself called send command. AWS is that's what I like about it. It has a lot of API calls that are extremely like specific to things we want. Like, it actually has one called send command, which is basically a way to, it's basically a command line event where the user is executing a command. So that's one way to kind of look for that. And then in the request parameters, you would see the word SOCAT. And the other way is the SSM inventory to look for applications installed, where you're going to see where you want to look for the word SOCAT. The complete mission. This is basically the last final stage for any threat actor to complete their mission. And that could involve multiple things like exfiltration, where in this case is the most important final mission for Scattered Spider. They also tend to do some anti-detection and recovery prevention methods to make sure that you're not able to detect them and also not able to recover the data that they have exfiltrated, deleted, or encrypted. And the third stage is ransomware deployment. I'm not really going to get into how to detect ransomwares because that my best suggestion for that is to look through all of the indicators of compromise you might see in various open source blogs and do a full search for those indicators of compromise. That's one of the best ways to kind of merge all of these hunts into one and also make sure you're capturing ransomware if there's any. I'm going to get into the first two. One of the first is exfiltration. You want to be able to detect if like huge amounts of data has been stolen or left your environment and gone to and has actually left the environment to a threat actor's command and control channel or any other site, any other cloud account. With M365, again, there's two ways to go about this. One is your endpoint data exfiltration. That is happening, that is something you can detect by getting into device network events. With device network events, you're trying to look for all these exfiltration sites. Mega NZ, Pastebin, bit.ai, SendSpace, pCloud, all of these are very commonly used exfiltration sites. If you see connections to them, definitely something to flag. It's not a bad idea to also look for legitimate cloud like Dropbox, Box, Google Drive, any of these things. If you see an external connection to them, that's something you definitely have to query and look at. The other thing that I also want to focus on is SharePoint. Like we assume that from the beginning, they've had access to an M365 account, which means that they also have access to OneDrive, SharePoint. So we want to be able to see if they went into SharePoint and downloaded actual company data. And there's three. This is something you can look at on the UI as well by going to audit under the purview portal that I spoke about in the beginning. The friendly names or the operation names you're going to be looking for is file downloaded, file sync downloaded, and file accessed. File access doesn't necessarily mean there was a download, but the first two definitely means that there was a download. That means that the file that they downloaded exists outside of the environment. This is just another really interesting way to look for data exfiltration when it comes to like the VMs they accessed or created. Before I get into this, there's another way to do this. The other way is basically to look, if you do not have any of these enabled here, the other way to do this is to look at costs of your Azure, costs of your Azure or AWS account. If there's a spike in costs, it usually means it's because of data egress, and it's something you note. It's something you have a detection rule for maybe, and make sure you see that, because that's another way you can tell that data was exfiltrated from that particular VM, that particular account, or that particular subscription. In this case, we are trying to look at each VM and the data from each VM. This will be under the Azure portal. You look for the VM name. You can literally put the VM name in the search bar. And once you click on it, it's going to be on the left-hand panel. It's going to be under monitoring and metrics. Under metrics, there's a drop down again to choose for what metric you want to see. And in that, you'd go for network out total and adjust the time frame to 6 months, 3 days, 24 hours. You adjust the time frame and you'll be able to see a beautiful graph that will tell you if there is a spike. So you don't have to go through building these graphs or pivot tables yourself, you're just going to be able to see a spike if you see one. And the spike and the y-axis will also have the bytes, GB in GB in MB, whatever it is. You're going to be able to see how many bytes at that spike, how many bytes egressed out of the network. The same thing with AWS. With AWS, it's going to be something, it's going to be S3, right? Like the exfiltration happens from an S3 bucket. So with that, there are two ways to kind of see this. You're going to go back to your CloudTrail logs. This S3 storage bucket logs have to be enabled. If they're not, you'll not be able to see the first one. With the CloudTrail logs, you will be able to look for two types of event names: get object, put object. So get object is to get the data, and put object is to download the data. So you both these will give you a good. Both these will basically mean that that data in that bucket was the object in that bucket, the objects in the bucket, and the data in that bucket was exfiltrated. The second one is basically the equivalent to my looking at the device network events. I want to look at the DNS logs here to see if there was any connections to Mega, NZ, vTransfer, pCloud, and all of these other exfiltration sites. This even AWS has a similar thing here. In EC2, we want to be able to see if each EC2 instance, how much data went or left the network. You go to AWS Management Portal, CloudWatch, Metric, and under Metrics, you can type in the EC2 AWS namespace. You can type in EC2. Per instance metrics, you can select that, and then under network, and you look for like the network out of bytes. You click on that, and then you're going to get this beautiful graph again. You'll have to filter out for the instance ID you want to look for, or the instance ID is the EC2 instance ID. You're going to have to filter for that, and once you hit that, you're going to see the graph again. There's a similar graph which is going to tell you how much data at the spike there, how much data left the network. Getting into anti-detection, recovery prevention, you're just trying to look for ways that they might have like deleted backups, deleted shadow copies, stopped like Defender. So the way to do that when it comes to UI is you go to Admin Center, Monitoring and Health, Audit Logs. You're going to look for any deletion of users, groups, any users disabled, and applications that are crucial to the like security monitoring, if anything like that was deleted. The same thing with the query. We're just going to look for delete shadows, stop when defend, and disable real-time monitoring, things like that. When it comes to AWS, you want to look for delete bucket, delete user, delete access key, terminate instances, things like that. So that is pretty much it. That's all of the hunts, the hunting methodologies from the start to end of the MITRE attack lifecycle. This is just a small recommendation slide that I just want to talk over, because once you have hunted for your threats and you find threats, you want to go back and figure out why it happened, or how you can prevent this from happening again after containment. So all of this is just simple recommendations. When it comes, because UNC3944 is known to do a lot of social engineering, when it comes to help desk calls, use on camera, use ID verify, make sure you're verifying the individual that's trying to change the password or add an MFA. You want to make sure that if there is no in-house VPN that's being used from a system, do not allow that login to go through. Block any sort of RDP from inbound RDP to like all these admin accounts. Any new VMs that suddenly pops up, flag them. Ensure VM backups are isolated and separate, so that if there is an incident, you have your backups. Block any sort of egress for DCs. There's no need for that. And then just alert on all of these remote access tools and recon tools and info stealers. And yeah, that's pretty much it. This is, again, just some references. A lot of this is coming from blogs, from the Google Cloud blogs. And nothing would be possible without Gemini, and nothing would be possible without really going through my attack frameworks from the website itself. They have a plethora of resources to understand the whole life cycle, and in particular to UNC3944 as well. And that's it. Thank you. We still have 5 minutes. I do apologize if I went over things quickly. We should have 5 minutes for any questions. Please feel free to drop them. I'll be able to take a look, and I'll do my best to answer them. Since we have such, we don't have much time, I am gonna drop my LinkedIn. If there's any questions or in general anything at all that I can help with, do not hesitate to reach out. I'll do my best. I'm gonna drop in my LinkedIn here, and yep, so that should be up. I'm going to wait for a minute, and if there's not really any questions, I will end the talk. Thank you so much for everyone who joined. I really do appreciate it. Okay, we see a question. How do you use Gemini to Thrunt? I don't use Okay, so I don't use Gemini. So the question is, how do you use Gemini to Thrunt? I don't use Gemini to Thrunt, but what I do believe in is to use Gemini to optimize your queries. I think that's where that comes into play. I don't believe in giving my logs to Gemini. I don't believe in that. Like, I don't want to, whatever the outputs that I get from my query, I'm not giving that to Gemini. I'm going to look over that, because that's very important. You need a human touch for that. What I will take Gemini's help with is to come up with queries. I'm not going to focus on learning KQL to make sure I don't make syntax errors. I'm going to focus on what I want to do, tell Gemini to come up with the query. Also, because at my work, I work with different clients who use different EDRs, different platforms, different SIEMs. They could be using GCP, they could be using Splunk, they could be using Databricks, whatever they're using. I should be able to go into their environment and be able to hunt. What's a lateral movement? So I have a question here. The question is, what's a lateral movement? Lateral movement is basically when a threat actor who's gained access to one account is trying to move from that account to another account by laterally moving. So they're trying to move to another account that either they're moving because that account or that device basically has higher privileges or houses your file share system, might house credentials, might be a domain controller. So lateral movement is the movement of the threat actor from one system to another using a compromised account. So yeah, threat hunting in general, it's all about what your approach is. But most of the hunts I talked about today, they are going to remain the same for different threat actors as well. When it comes to like suspicious logins, you want to be able to see that. You want to be able to hunt for that no matter who your threat actor is. When it comes to looking for data expel, you still want to hunt for that no matter who your threat actor is. So threat hunting is it's all about your agenda. What are you trying to accomplish? And in my case here, for this talk, it was to see if the threat actor scattered spider exists in our environment. So that was my agenda today. But threat hunts are very vast and varied in their motive, in what you're trying to achieve. It's very different than detection. Detection rules are a whole other topic, and detection rules are going to be in place for you to get alerted to certain incidents, a certain activity, suspicious activity, whereas threat hunt is you going in once a week, once a month, once a year, and making sure that there is not already a threat in your system. So yeah, that's the difference. That's threat hunting is a very custom thing, and even in the work I do, it's I work with different customers who want it done a different way for different purposes. So yeah, I think we're up on time. I have dropped in my LinkedIn, so feel free to text me, connect with me for anything. I hope this was useful, and thank you so much for being here, for taking time out to be here. And yeah, thank you.